Welcome back, Cat 5 class. In the last chapter, chapter 9, we covered creating section views, sketching by hand. In chapter 10, we're going to still cover section views, but we're going to use AutoCAD in this chapter. Next slide. Quick review of alphabet of lines. So let's take a look at line thicknesses or line weights. Okay, so visible line, object line is 0.50 to 0.60 millimeters in thickness. And as you can see, hidden lines, center lines, phantom lines, dimension, and extension lines are about 0.30 to 0.35 millimeters in thickness. So we make them thinner so that we don't mix them up with object lines. And real quick, phantom lines have two little dashes, center line, one little dash, and dimension lines and extension lines are about 0.30 to 0.35 millimeters in thickness. Okay, now the one that we're going to be using in this chapter is the cutting plane line, and we do want it to stand out from these other lines and the object lines. Either we're going to make it thicker so it can stand out, or we can even make it thinner. Next is section lines. So when we do a section cut, remember we leave teeth marks when we cut through a piece of metal, aluminum, wood, cheese. You can see the teeth marks where it cuts through the solid. So section lines are 0.30 millimeters in thickness, and we tend to angle the pattern so that we don't mix them up with any of the hidden center lines, dimension lines. So we tend to give it an angle so it can stand out on its own. We can also use rectangular patterns, which tend to also stand out on their own, separate from these other type of lines. And if we take an imaginary cut, you pretty much freestyle a break line. So a break line is just an imaginary cut where you just want to remove a piece of it. And since we are cutting the solid, an imaginary cut, we do make it the same thickness as the visible line. We're not going to be using this break line in this class. Next slide. Let's take a look at some examples of cutting plane lines. So depending on which standard you're using, whether it's an American standard, an international standard, or maybe even a company standard, they do all have some similarities. For example, they'll use two arrowheads, as you can see, and you do label the section cut with two letters. So this would be section AA. We do label it the same way. You tend to put the letter somewhere around the arrowhead. It can be next to it, below it, in front of it, or on top. That's optional as to where you place the letter. Now, some of the differences are the line types. So here we have a phantom line, two little dashes. In this example, we have dashed lines like a hidden line. You can also use a center line, but typically you'll see either a dashed line like a hidden line or a phantom line, the double dashes. And also another difference is the line weight. So the thickness can be anywhere from 0.60 or higher. You tend to make it a little bit thicker than the object line. So if the object line is 0.50, you can make the cutting line 0.60 or a little bit thicker. You want it to stand out separate from an object line. Or you can even go with a thin 0.30 millimeter thickness line, similar to a hidden line or dashed line. We try to use different thicknesses, but since section lines stand out on their own, it's okay if you do use a similar thickness as a hidden or center line. I prefer to use the thick phantom lines, but they're all very common. It's a matter of preference. Again, follow your company standards. Next slide. So let's take a look at an example of a section view. So this is third angle projection. So most American companies will use third angle projection. Here we have the object isometric view. We're going to stand here and look inward, identify our front view, which gives us the most information. So there's our front view. And project 90 degrees, grab by the nose, rotate 90 degrees upward. Here's our top view, our projection view. Okay, so we're going to take our top view and we're going to create a section view, and using our cutting plane, our line representing the cutting plane, In this example, they're using center lines, one little dash. You can use a double dash using a phantom line, or you can use a dashed line like a hidden line. And notice again how thick the line is in comparison to the object line. Okay, so it's a lot thicker, 0.60 or thicker than the object lines. You want this to stand out separate from the other lines. And the arrowheads, 2 arrowheads, and we have the letter twice. Okay, so this is going to be section AA. All right, so the arrowheads tell us to keep the top half. So again, in third angle projection, the arrowheads are telling us to keep the top half, but we project in the opposite direction. In this case, downward. So now our front view has been turned into a section view. Notice section view A-A. You always call out the letter twice. So section view A-A. And as you're cutting through the top view, here you're cutting through the solid, you're cutting through the shaft, and you're going to put hatching lines, which are 0.30 millimeters in thickness. And then when we cut through the hole, this is an opening, this is open space. And we're not cutting through material in this area, so we're not going to leave any teeth marks from the saw blade. So this is open space. We do not use any hatching in the open area. And as you go beyond the hole, once again, the teeth of the blade are making contact with solid, cutting through the solid, leaving teeth marks. Okay, so we hatch that area. And then we encounter the smaller shaft. And as you cut through the shaft, you're cutting through material until you encounter the small hole. This is open space, so you do not hatch that area. And finally, you go through the last part of the solid, and you also hatch that area. So notice how the hatching lines stand apart from object lines and center lines. You want the hatching pattern to stand apart from everything else. You do have to use the same pattern throughout. So in this simple single line pattern, which is about 30 degrees, angle of 30 degrees, you want to use the same pattern throughout. You cannot change the pattern as you go from one hatching area to another. You cannot have this, let's say at 30 degrees, this one at 45, this one at 60 degrees. They all have to use the exact same pattern throughout. And one thing to notice is there's no hidden lines. No hidden lines allowed in a section view. And the reason we do not include hidden lines, it's because it'll get lost within the hatching pattern. So to avoid causing confusion, the rule is you do not put hidden lines in a section view, but you do place center lines. Okay, now let's take a look at first angle projection. Next slide. Okay, first angle projection, which we're not going to use in this class. Let's take a look at an example of first angle projection. So we have the same object, and here's our top view. Here's our front view. Notice the difference when using first angle projection, which most that follow the international standards will use first angle projection. Notice some minor differences. They use the thinner line. It's not a big deal. I also see American companies use the thin line on the cutting line, 0.30 millimeters, same thickness as a center line or a hidden line. We still have the 2 arrowheads and the 2 letters. And you always start with in alphabetical order. Once you've used the letter A, then you move on to the letter B and so on. And you go through the alphabet. All right, so minor differences between first angle and third angle projection. The arrowheads will tell us to project downward, and the arrowheads will also tell us to keep the bottom half. So it's a little different from third angle. So once again, first angle projection, the arrowheads tell you to keep the bottom half and to project downward. Okay, first angle projection, you grab from the back. In third angle projection, we grab by the nose. So in this case, we're going to grab from the back and rotate 90 degrees downward. And our front view now is our section view. Let's take a look at another example of first angle projection. Next slide. Here's another option you could have had using first angle projection. You have, in this case, your front view, and you can call this your top view. It doesn't really matter. Okay, so in this case, the arrowheads are pointing upward, keeping the top half, and projecting upward. Not same as third angle. And we have our section lines, same as third angle projection. And again, we're not going to be using first angle projection in this class. I just wanted to show you some examples of first angle projection just to compare to third angle. And again, notice no hidden lines. Next slide. So here is one of the problems from your assignment in this chapter. And you are going to have to create your own drawing from scratch. So I will no longer provide an AutoCAD file for you with layers included. So you're going to have to either set up your own layers, or you can use one of your old drawings, save as with the new different part number, so you don't have to recreate layers from scratch. I want you to notice that there are no hidden lines in the section view. No hidden lines. Hatching lines are 0.30 millimeters in thickness, just like the center line is 0.30 to 0.35. And same with the hidden lines, 0.30 to 0.35 millimeters in thickness. Object lines are about 0.50 to 0.60 millimeters in thickness. And you do want the cutting plane lines to be a lot thicker than the object lines. It could be 0.60 to 0.80 millimeters in thickness. Don't forget to use arrowheads. And if you want to use the double lines for phantom, or you can use center lines or dashed lines for your line type. Next slide. So you're going to have to set up your own layers from scratch since you're studying the AutoCAD file from scratch for this chapter, sectioning in AutoCAD. Or unless you use one of your old AutoCAD drawings that already have some of the layers set up, just open that file and save as with the new part number or file name. Okay, let's say you're setting up your own layers. So you go to the layers panel up in AutoCAD above, click on the layer properties, and you'll have the layer properties window pop up. I already have all my layers in place. If you're ready to create your own layer, click on this icon, and then you'll be able to type in your name for the layer. Keep it simple. AutoCAD is picky about using symbols and maybe even spaces when it comes to naming a layer. Keep it simple. Once you've named your layer, in this case, let's take a look at the cutting plane. So we'll name this the cutting plane layer. That'll represent the line that we're going to use to cut with, an imaginary cut. If you want to change the color, click on the box. Now typically when you start a new layer, the properties that it chooses, it'll pick from whichever is currently active. See, the visible layer is currently active with the check mark. It lets you know this is the layer that's currently active in AutoCAD. And whatever properties, colors, line types, etc. you have for that layer, it'll automatically populate it in your new layer. So just simply click. If you want to change the color, you'll have a rainbow of colors to choose from. For the line type, we don't want to use continuous, so we'll just click on the line type. It'll give you the select line type window. So as you can see, I can pick from center lines, solid continuous lines, dash dot lines, dashed lines, etc. And we have phantom line here. That's the one with the double dashes. Now, if you don't see phantom line listed, then you have to go to load. So these are your your personal list of line types to choose from. If you don't see a line type that you want to use, then you have to click on load, and it'll load a library of different types of line types available. So from here, you'll just scroll down, pick the phantom line type, hit OK, and then it'll load it in your favorites. And then select it and hit OK, and then it'll load it into your line type option for cutting plane. And to change the line weight, simply click on the line weight and you'll have a list of choices, and it'll be in 1/10 millimeter increments, 0.10, 0.20, 0.30, etc. Pick the desired line thickness, and for cutting plane we want to use anywhere from 0.60 up to 0.80 millimeters in thickness. You're also going to want to create a hatching layer. So you're going to pick a hatching pattern. So might as well create its own layer for hatching. So click on the create new icon or create new layer icon, and it'll load it. Name it hatching. Click on the box to change the color. The line type you want to use is continuous, and you want to keep it at 0.30 millimeter in line weight and thickness, same as a center line or a red hidden line. Okay, once you're done setting up all your layers, you can always come back and change colors, line types. So if you make a mistake or you don't like the color, you can always come back and update it. Once you're done, you can exit. Click the X to exit this window. Or if you want to just minimize it, click on this small icon. It'll just reduce everything to the single bar. Most of you will just want to close it out and just hit the X. Next slide. AutoCAD does not have a command. It doesn't have a cutting plane command that'll draw this for you in one shot. So you're going to have to manually draw your elements. Okay, so when you're creating a cutting plane line, the author recommends to manually draw a line using a phantom line. So you use the line command to draw your cutting line. Use the line command to draw the leader, and manually draw a triangular shape, or you can use a polyline to create an arrowhead. Unfortunately, AutoCAD does not have an arrowhead command like other softwares. You're going to have to manually draw one, and I'll show you that how to do that in the assignments. Now, even though the author recommends using a phantom line, which I prefer, the double dash, you're welcome to use a center line or dash line. So you will have to create a layer for cutting planes. Okay, so you will have to create its own layer, and you will also have to create a layer for section lines. And for section lines, just use continuous lines, and it's preferred that you go at an angle so that the cutting lines stand out from the other lines. Next slide. So here are some common hatching patterns that you'll find in drafting. Your textbook will provide you a list of patterns, and these patterns you will also find in the AutoCAD software, so you can pick from these patterns. In mechanical drafting, whether it's aerospace, machine shop drawings, or automotive, manufacturing, the most common pattern you'll find is the Ansi 31 pattern. It's a very simple pattern, single lines at about 45 degrees, and you'll see this pattern about maybe 90% of the time. In architecture, you'll see other patterns like brick patterns, earth patterns. I don't see the concrete pattern here, but it's a combination of dots and sand for concrete. For example, for the footing, foundation for a building or a house, for example. But you'll see some more of these patterns that are dedicated for architecture and also civil engineering. We'll stick mostly to the Ansi pattern 31 and 32, but you're welcome to use any pattern that you like for your assignments. Next slide. And once again, these are the most common patterns you'll see in aerospace, manufacturing, automotive, mechanical drafting. So even though Ansi 31 is dedicated to iron, and Ansi 32 standard is dedicated to steel, and Ansi 33 standard represents brass, bronze, or copper, I've seen it mixed. So back in the good old days, you had to stick to the pattern, following the standard. But nowadays, I see drafters take the freedom of picking any pattern they like. These are the most common patterns that you will see on a drawing. Follow your company standards or whatever your department standards, whatever they follow. Next slide. To access the hatching pattern command in AutoCAD, look below the ellipse. Here we have the hatching pattern command. So we have hatch. There's also gradient where you can mix colors and you can change the brightness of the colors, the mixture, the pattern of colors, which we don't really use in mechanical drafting, but it's great for visuals. And we also have boundary patterns, but we're going to mostly stick to your traditional hatching patterns. Once you click the command for hatching, you'll have this panel pop up, allowing you to pick a different pattern. It'll default to the Ansi 31, the most common pattern. You can use the arrowheads to go down and pick from the different listed patterns. One thing to note is that if you want to change the angle of the pattern, so let's say you already used this pattern, which is at 45 degrees. If you want to reuse this pattern for a different object, and but you don't want it to get mixed up with the original object, you can simply change the angle. So this has a pattern at a 45. You can increase the angle, let's say to 15 degrees, and it'll rotate this by 15 degrees. You can type in 90, so it'll rotate at 90. Okay, so that's one way of changing the pattern. Or you can scale it. You can scale it down or up to tighten the pattern or loosen up the pattern so it stands out separate from this standard. Next slide. Once again, if you want to alter an existing pattern, once you've selected the pattern, you can change the angle, type in the angle. So once again, for example, if you want to rotate it 90 degrees, type in 90 and tab or go to another window and you'll automatically see the pattern rotate 90 degrees. If you want to change the scale, so the scale will change the spacing between the lines. If the spacing between the lines is they're too far apart, you can change the scale maybe to a half scale, type in 0.5, and you'll see the spacing cut in half. Sometimes when you apply a pattern like Ansi 31, it appears to come out solid. That's just telling you that the lines are too tight together. So you're going to have to increase the scale, maybe try a scale of 10 or 5, and then you'll see the spacing between the lines. Next slide. When selecting a boundary to hatch, you have two options. You can either select the pick point option, and you'll just simply select inside of a closed profile, and it'll auto detect any inside profiles. Or you have the option to go with select boundary. So if you have a boundary that's joined as one entity, like a rectangle, for example, you can just simply select it and it'll hatch the entire inside. And I'll demonstrate these in the following slides. And once again, if you want to take a pattern, change the angle, type in the number, 15 degrees, 45 degrees, etc., and click away or tab so you can see it change on your drawing. You can see it rotate instantly, and also for scale. Once you've created your hatching pattern, you're happy with the angle, with the spacing, then you can just simply click on the closed icon to exit the hatching command. Next slide. Before using the boundary command, you need a closed profile. So let's say before creating your hatching, you use the rectangle command to create your rectangular profile and the circle command to create your circle. And let's say you're ready to hatch. So you click on the hatch command and the ribbon or panel will pop up. And there's two options. You can either hatch by selecting a boundary or pick points. So let's first look at select boundary. So click on select boundary and select the edge of the rectangle. Since it's one entity, when you use the rectangle command, it'll create the four sides and see it as one entity. And by selecting any edge of the rectangle, it'll automatically hatch everything inside that profile. Now let's take a look at the pick points option on the next slide. If you go with the second option, pick points, instead of select boundaries, then you pick inside the boundary. So in this case, we want to hatch the inside of the rectangular profile. Pick a point inside. Now when you pick a point inside the rectangle, if there's any profiles inside, it'll view it as an island and it'll avoid hatching those inside areas. If you wanted to also hatch the inside of the circle, then you can then click a point inside the circle and it'll also hatch that area. But the good thing about pick points is it detects any inside profiles and it'll view it as islands, and it will avoid hatching those areas unless you also pick inside of this second profile. And just to end, need to give you a warning. Anytime you're using hatching, hatching can only be used if there's a closed profile. So let's say you created this rectangle using the line command, and there's a little gap. It can be the smallest gap. Let's say you didn't close it. You didn't snap correctly to object snap to close the profile. The tiniest little gap will not allow you to hatch. If it does hatch, it'll start hatching, then go beyond your profile until it finds a closed profile, and it'll hatch outside if there is a larger profile outside. This may cause issues with your computer, not only with AutoCAD, but with other softwares like SolidWorks, CATIA, maybe Inventor. If you hatch inside a profile where there's a gap, it will keep going, looking for the closed profile, a completely closed profile, and it may slow down your computer. It'll eat up a lot of memory, and it may even freeze your computer. So be aware of it. Make sure when you use the hatching command that it's a closed profile and no gaps. If you're having issues hatching and it's driving you crazy, go ahead and zoom in at the corners and make sure that there are no gaps. You have to really zoom in, roll the wheel, and zoom in. End of lecture.